Yeah, good afternoon, students. Good afternoon, students. Today we'll start mathematical induction long answers and mathematical induction. Mathematical induction long answers, okay? Right. Prove by mathematical induction. 2 into 3, 3 into 4, 4 into 5 plus so on plus up to n terms. That is n into n square n into n square plus 6n plus 11 by 3. Right? We are going to prove this by mathematical induction. Let S of n be the statement. Let S of n be the statement. क्या statement है वो? 2 into 3 plus 3 into 4 plus 4 into 5 plus so on up to n terms is equal to n into n square plus 6n plus 11 by 3. Here, what is missing is nth term. So let us find first nth term. So here 2, 3, 4. The product of first terms dot dot are in AP. So arithmetic progression nth term mane Tn is equal to a plus n minus 1 into d. That is 2 plus n minus 1 into common difference is 1. 2 plus n minus 1. That is n plus 1. Okay. Now next, second term products. Is it clear? The second term products क्या है देखो 3, 4, 5. So 3, 4, 5 are in AP. That is Tn is a plus n minus 1 into d. They are in arithmetic progression. That is 3 plus n minus 1 into, again common difference is 1 only. So therefore your nth term, I am writing the nth term here. Therefore your nth term, what you got? N plus 1 into n plus 2. It's a statement लिखेंगे. Therefore 2 into 3 plus 3 into 4 plus 4 into 5 plus 1 plus n plus 1 into n plus 2. That is only now your nth term is n plus 1 into n plus 2. That is equal to n into n square plus 6n plus 11 by 3. Now nth term was not given. We found the nth term. Is it clear? Now for n equal to 1, n equal to 1 LHS. That is 2 into 3, 6 RHS. N equal to 1 square plus 6 plus 11 by 3. That is 11 plus 1, 8. 11 plus 1, 12. 12 plus 6, 18 by 3, 6. So therefore, LHS equal to RHS. Therefore, the statement P of n is true for n equal to 1. Now assume the statement P of n. Assume the statement P of n is true for n equal to k. So directly, instead of n, you put k directly. So what I'm going to get? Into 3, 3 into 4, 4 into 5, plus so on, plus k plus 1, k plus 2, that is equal to k into k square plus 6k plus 11 by 3. Instead of n, you put, instead of n, you put k. That is k into k square plus 6k plus 11 by 3. 2 into 3 plus 3 into 4 plus 4 into 5 plus 1 plus k plus 1 into k plus 2. That is equal to k into k square plus 6k plus 11 by 3. Put it as 1. Okay. Next, to prove the statement, P of n is 2 for n equal to k plus 1. Now for that, what I should do? Add k plus 1th term on both sides of 1. So what is your nth term actually? Your nth term is this. What is your nth term? This is your nth term. In this nth term, you put n as k plus 1. Is it clear? So that is, so k plus 1th term, k plus 1th term is k plus 1 plus 1, k plus 1 plus 2. Instead of n, you are going to put k plus 1. That is nothing but k plus 2 into k plus 3. That is nothing but k plus 1 into k plus 2 into k plus 3. This we are going to add to equation 1 on both sides. Is it clear? Here we are going to add both sides of to equation 1, that k plus 1th term, whatever we got. So that is nothing but, I'm adding 2 into 3 plus 3 into 4 plus 4 into 5 plus so on plus k plus 1 into k plus 2 plus k plus 2 into k plus 3, that is equal to, we are adding here, that is equal to what it was. Here we are going to add k into k square plus 6k, like that, right? So k into k square plus 6k plus 11 by 3 plus k plus 2 into k plus 3. So we've added k plus 2, k plus 3 on both sides of equation 1. So what is equation 1? N equal to k, assumed statement. That is your equation 1. Okay. Now start simplifying your LHS part. We are going to simplify this part. First, k cube plus 6k square plus 11k by 3. Here k square plus 5k plus 6. Now k cube plus 6k square plus 11k plus 3k square, 3 5s are 15k, 3 6s are 18. It's by 3. K cube plus 6k square plus 11k. 3k square, 3 5s are 15, 3 6s are 18. Okay. That is k cube plus 9k square. K cube plus 9k square plus 26k plus 18. It's divided by 3. Okay. Now, here it is a cubic equation. So here I'm writing separately. So here k equal to minus 1 is a root. If you want, you can check it. If you put minus 1 plus 9, 8, 8 plus 18, 26. 26 minus 26, because k is minus 1. So I get 26 minus 26 is 0. So k equal to minus 1 is a root. K equal to minus 1 is a root. Means k plus 1 is a factor. Then by using synthetic division, k equal to -1 is the root. 1, 9. By using synthetic division, 1, 9, 26, 18. Now, this you put 0. I hope you know synthetic division. So 1 plus 0 is 1. -1 into 1 is -1. This is 8. -1 into 8 is -8. 26 minus 8. 26, 26 minus 8 is 18. -18. See, at last what I got is 0. Now this I am going to write it as k plus 1. Here only I am continuing. K plus 1 into, right? Now this cubic equation, I am going to write it as, already I know 1 is k equal to -1 is the root. So k plus 1 into, this is your k square plus 8k plus 18. Is it clear? So k plus 1 into k square plus 8k plus 18. It's divided by 3. Now k plus 1 into, here I will write it as k square plus, wherever you get n, there you should get n plus 1. Okay, so k square plus 2k plus 1. I wrote it separately. From 8k, I separated 2k. Then what I will get is 1 more 2k. And from 18, I separated 1. So what I get is 70. Whole divided by 3. That is nothing but k plus 1 into k plus 1 whole square. This becomes, and 6k plus 6 plus 11 by 3. That is k plus 1 into k plus 1 whole square plus 6 common k plus 1 plus 11 divided by 3. See, in your RHS, wherever I am having n, I got k plus 1. That is only a mathematical induction, is right? Therefore, the statement P of n is true for n equal to k plus 1. Oh, sorry, S of n. Therefore, the statement P of S of n is true for n equal to k plus 1. Therefore, by mathematical induction, by mathematical induction, the statement P of n is true. S of n is true for all n belongs to n. This is how you are going to do. Once again, you can have a whole look. Here, nth term was not given. First, we were finding the, so prove by mathematical induction. This is a question, very important, right? So nth term was not given. We are finding the nth term by checking your first terms of 2, 3, 4. 2, 3, 4, they are in AP. Next, 3, 4, 5, they are also in AP. So A plus n minus 1 into D. Is it clear? A plus n minus 1 into D. Like that, you will get your nth term. Once I get nth term, I replace that nth term there. Now I checked for n equal to 1. N equal to 1 means first term. 2 into 3, that is 6. And RHS, put n equal to 1. RHS means this. RHS is this. Put n equal to 1. So when you put n equal to 1, I get 6 equal to 6. So the statement is true for n equal to 1. Now assume the statement is true for n equal to k. Directly you put n equal to k on both sides. Next, we have to prove for n equal to k plus 1. Means add k plus 1th term on both sides of 1. So how to get k plus 1th term? Every sum the same procedure. Substitute n as k plus 1 in your nth term. Substitute n as k plus 1 in your nth term. Is it clear? So that is k plus 2 into k plus 3. So this is how. Then simplification. Whenever you get a cubic equation, you are going to simplify by doing synthetic division. Before that, first you are going to find one factor, k equal to -1. Okay, right. Next one. Prove by Prove by mathematical induction. Prove by mathematical induction. 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to n terms is equal to n into n plus 1, n plus 2, n plus 3 by 4. Let S of n be the statement. Let S of n be the statement. What is that statement? 1 into 2 into 3 plus 2 into 3 into 4 plus 3 into 4 into 5 plus so on up to n terms. That is n into n plus 1, n plus 2, n plus 3 by 4. So again, your nth term is missing, correct? Your nth term is missing. Again, let us start with nth term. How to do that nth term means here, see the product to first terms. See the product to first terms, that is 1 comma 2 comma 3 dot dot r in AP again. So Tn is equal to a plus n minus 1 into d. A plus n minus 1 into d, your d is nothing but common difference. It is 1 plus n minus 1, what I got is n. Right? Next, product of second terms I'm talking about. Right? What is that? This, and this. Second numbers in the product, each and every term. That is 2 comma 3 comma 4 dot 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 are in AP. That is Tn is equal to again a plus 1, a plus n minus 1 into d. What is a? 2 plus n minus 1 into 1. 2 plus n minus 1. That is n plus 1. Next, third terms, that is this, and this. The third terms I'm talking about. So 3, 4, 5, 3, 4, 5 are in AP. It means Tn is equal to 3 plus n minus 1 into 1. 3 plus n minus 1, that is n plus 2. So therefore your nth term is, therefore your nth term. So what is your nth term we got? N into n plus 1 into n plus 2. Now again write down the statement. We got the nth term. So therefore 1 into 2 into 3, 2, 3, 4, 3, 4, 5 plus 1 plus n into n plus 1 into n plus 2. That is equal to n into n plus 1, n plus 2, n plus 3 by 4. So this is your nth term. This is your nth term. Okay. Now first, for n equal to 1, LHS 1 into 2 into 3, 2 3s are 6. Next RHS, n equal to 1 you put 1, 1 plus 1, 1 plus 2, 1 plus 3 divided by 4. 2, 3, 4 by 4, 2 3s are 6. Correct now? Therefore, your LHS equal to RHS. Therefore, the statement S of n is true for n equal to 1. Correct? Now we have to assume the statement S of n is true for n equal to k. Assuming the statement S of n is true for n equal to k means what? Directly you will substitute n as k. Is it clear? That is 1 into 2 into 3, 2, 3, 4, 3, 4, 5, plus so on, plus k into k plus 1, k plus 2. That is equal to k into k plus 1, k plus 2, k plus 3. It is divided by 4. This I will put it as 1. N equal to k assumed statement is always n equal to 1. I mean, always that is the first equation. And for this equation, you are going to add k plus 1 the term on both sides. Yeah. Now, to prove the statement S of n is true for n equal to k plus 1. For that, what I have to do? Add k plus 1th term on both sides of equation 1. So how to get that k plus 1th term? Instead of n, you put k plus 1 in your nth term. So what was that nth term? It was n into n plus 1. So k plus 1, k plus 1 plus 1, k plus 1 plus 2. Add k plus 1th term on both sides. How to get k plus 1th term? Instead of n, you will put k plus 1. K plus 1, k plus 1 plus 1, k plus 1 plus 2. That is k plus 1 into k plus 2 into k plus 3. Okay. Add k plus 1 into k plus 2 into k plus 3. That is a k plus 1th term. Is it clear? Now, we are going to add to the equation 1. What was that equation 1? N equal to k assumed statement. That is 1 into 2 into 3, 2 into 3 into 4, 3 into 4 into 5, plus so on, plus k into k plus 1, k plus 2, plus k plus 1, k plus 2, k plus 3. This we added. That is equal to what it was? K into k plus 1, k plus 2, k plus 3 divided by 4. Correct? K into k plus 1, k plus 2, k plus 3 divided by 4 plus k plus 1, k plus 2 and k plus 3. Add this term. Which term? Add this term. Add this term on both sides of equation 1 which we added. Now I'm going to simplify. I'm going to simplify your RHS part. That is k common k plus 1, k plus 2, k plus 3 common. When I take this common, what is left out? K by 4 plus 1. That is k plus 1 into k plus 2 into k plus 3, k plus 4. Take LCM by 4. Now instead of n, you got k plus 1 or not? Check it. Into k plus 1 plus 1. Correct? Into k plus 1 plus 2. Into k plus 1 plus 3. Whole divided by 4. Is it clear? Whole divided by 4. Whole divided by 4. See, k instead of n, I got k plus 1. K plus 1 plus 1. K plus 3, I will write it as k plus 1 plus 2. K plus 4, I will write it as k plus 1 plus 3. That's all. Instead of n, I got k plus 1. Correct? Instead of n, I got k plus 1. Therefore, the statement P of n is true for n equal to k plus 1, S of n, S of n. Therefore, the statement S of n is true for n equal to k plus 1. Therefore, compulsory you have to write this statement. Therefore, by mathematical induction, the statement S of n is true for all n belongs to natural numbers. So clear? So this is only your problem is, it's very, very important. Again, nth term is not given. Whenever nth term is not given, you are going to find the nth term since they are in arithmetic progression. Is it clear? In each and every term, I am having product of 3 numbers. You take that first number in the product, you take the second number in the product, you take the third number in the product. They are in arithmetic progression. Like that, you will get your nth term as n into n plus 1 into n plus 2. Is it clear? Now next, for n equal to 1 LHS. LHS equal to RHS. So the statement S of n is true for n equal to 1. Assume the statement S of n is true for n equal to k. And add k plus 1th term on both sides. Adding after k plus 1th term on both sides, always you are going to solve this RHS part. How to solve this RHS part means, in your RHS in the given question, instead of n, you should get k plus 1. That is how you are going to solve it. Okay? Right. Next, most important again. Prove that 1 square into 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on plus again nth term. That what I have to show, n into n plus 1 whole square, n plus 2 by 12. Again nth term is missing, right? So let S of n be the statement. What is that statement? 1 square, first term this is. 1 square plus 2 square, second term. 1 square plus 2 square plus 3 square plus so on up to n terms. That is n into n plus 1 whole square, n plus 2 by 12. N into n plus 1 whole square, n plus 2 by 12. That is your nth term. Now, how to find the nth term? See here. So your nth term is nothing but bracket of. If at all, see, this is your first term, right? This is your first term. This is your second term. This is your third term. Like that, nth term means what? It should be product of, sum of n terms, correct? It should be sum of nth term. It should be sum of n terms. What is that n terms is? 1 square plus 2 square plus 3 square plus so on plus n square. That is nothing but nth. See, first bracket 1 square, second bracket 1 square plus 2 square. Third term, third bracket 1 square, 2 square, 3 square. Like that, nth bracket 1 square plus 2 square plus 1 up to n square. This is nothing but sum of the first n squares of first n natural numbers. N into n plus 1 into 2n plus 1 by 6. N into n plus 1 into 2n plus 1 by 6. N into n plus 1 into 2n plus 1 by 6. That is your nth term. Right? Sum of the squares of first n natural numbers. Now, once again, write down the statement. Therefore, 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on. Your nth bracket is this, that I am going to replace it with n into n plus 1 to n plus 1 by 6. That is equal to n into n plus 1 whole square, n plus 2 by 12. Now, same as usual, for n equal to 1, means first term. So, for n equal to 1, LHS, that is 1 square is 1. In RHS, you put n equal to 1. That is 1 into 1 plus 1 whole square, 1 plus 2 by 12. 1 plus 1 is 2. 2 square is 4 into 3 by 12. See 12. 4 3s are 12 gets cancelled. I get 1. So 1 only, no. Therefore, LHS equal to RHS. Therefore, the statement S of n is true for n equal to 1. Therefore, the statement S of n is true for n equal to 1. Now, assume the statement S of n is true. Assume the statement S of n is true for n equal to k. Now, n equal to k, you have to put n as k. That is 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square, right? Plus so on plus, instead of n, you put k. N into n plus 1, 2k plus 1 by 6. Correct, no? I said in your nth term, this is your nth term. This is your nth term. In this nth term, you put n as k. That only I did here. That is equal to, this side also you are going to put the same thing. What is that? K into k plus 1 whole square, k plus 2 divided by 12. K into k plus 1 whole square into k plus 2 divided by 12. Now, to prove S of n is true for n equal to k plus 1. So here, this is your equation 1 again. For that, what I should do? Add k plus 1th term. Add k plus 1th term on both sides of 1. Add k plus 1th term on both sides of 1. Is it clear? So what is your k plus 1th term? What is your k plus 1th term? Instead of n, in your nth term, instead of n, you put k plus 1. That is k plus 1 and k plus 1 plus 1, 2 into k plus 1 by 6. If you want, you can observe it. What was your nth term? N into n plus 1 into 2n plus 1 by 6. Instead of n, you put k plus 1. I did that only. That is nothing but k plus 1 into k plus 2 into 2k plus 3 by 6. You are going to add this on both sides of equation 1. Let us add, that is 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on plus k into k plus 1 2k plus 1 by 6 plus, now add this, that is k plus 1 k plus 2 2k plus 3 by 6. That is equal to, what is that? K into k plus 1 whole square, k plus 2 by 12 plus, again add this part, that is plus, I'm writing down k plus 1 k plus 2 2k plus 3 by 6. Now I am going to solve this RHS. Is it clear? See, same term has been added. Same term It has been added on both sides of equation 1. Is it clear? Now, once again I write the same thing, that is equal to RHS part, right? K into K plus 1 whole square, K plus 2 by 12. Correct, no? K into K plus 1 whole square into K plus 2 by 12 plus K plus 1 into K plus 2 into 2K plus 3 by 6. Now, whatever you can take common, you take common. So K plus 1 and 1K plus 2 I can take common, and 1 6 also I can take common. Then what are left out? 1K and K plus 1 will be left out by 2. Here K plus 1, K plus 2 I took common. 2K plus 3, 6 also I took common, no? So 1, 2, K, 1K plus 1 will be left out plus 2K plus 3. K plus 1 into K plus 2 by 6. And this is 2 is your LCM. This is K square plus K. 4K plus 2 3s are 6. Now K plus 1 into K plus 2 into K square plus 5K plus 6 by 2. That is K plus 1 into K plus 2 into factorize K square plus 3K plus 2K plus 6. It's divided by 2. Is it clear? Now that I am going to get it as K plus 1 into K plus 2 by 6. Correct, no? K plus 1 into K plus 2. 6 is also there. 6 into 2. 6 2s are 12. Here K plus 2 into K plus 3. So that is 12. It becomes, this becomes K plus 2 into K plus 3. If I factorize it, right? That is K plus 1. Now K plus 2 into K plus 2. K plus 2 whole square into K plus 3 by 12. Now that is nothing but K plus 1 is okay. K plus 2, you write it as K plus 1 whole square and K plus 1 plus 2 divided by 12. See, instead of N, you got K plus 1 in your RHS. Instead of N, you got K plus 1 in your RHS. Correct, no? Right. So therefore, the statement S of N is true for N equal to K plus 1. Therefore, by mathematical induction, the statement S of N is true for all N belongs to natural numbers. All N belongs to natural numbers. Is it clear? So this is you can have a look. These are very lengthy sums. So nth term is not given. Find nth term first. That is 1 square plus 2 square plus 3 square plus 1 plus n square. That is n into n plus 1 into 2n plus 1 by 6. That is 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on. Your n into n plus 1 into 2n plus 1 by 6 is your nth term. Okay. Then LHS equal to RHS for n equal to 1. Then assume the statement is true for n equal to k. In the statement, wherever you find n, you put k. Then add k plus 1th term on both sides to prove for n equal to k plus 1. Your k plus 1th term means in your nth term, in every sum, In your nth term, you put n as k plus 1. That is only, that will give you k plus 1th term. Is it clear? That is 1 square plus 2 square, and like this. Is it clear? Next, prove that 1 cube by 1 plus 1 cube plus 2 cube by plus 1 cube plus 2 cube plus 3 cube by plus so on up to n terms, n by 24 to n square plus this we are going to prove now. Again, by using mathematical induction, again nth term is not given. Let us see once. Let S of n be the statement. Let S of n be the statement. What is that statement? 1 cube by 1, 1 cube plus 2 cube by 1 plus 3, 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5, plus so on, plus up to n terms. That is n by 24 to n square plus 9n plus 13. Here your nth term will be, yes, listen. Here your nth term will be 1 cube plus 2 cube. See, first term 1 cube by 1. Second means 1 cube plus 2 cube. Third means 1 cube plus 2 cube plus 3 cube. Nth means 1 cube plus 2 cube plus 3 cube plus so on plus n cube. By it look like denominator is sum of the odd natural numbers. So that is 1 plus 3 plus 5 plus so on plus 2n minus 1. Why 2n minus 1? Sum of first odd n natural numbers. That will go to up to 2n minus 1. Out of 10, 5 will be odd, 5 will be even. Same way, out of 2n, n will be even, n will be odd. So what is that odd, last odd number? 2n is even, 2n minus 1 will be odd, like that. Now, sum of the cubes of first n natural numbers. That is nothing but n square into n plus 1 whole square by 4. Sum of the first odd n natural numbers. Please remember the formula, it is n square. Is it clear? It is n square. That is 1 plus 3 plus 5 plus so on plus 2n minus 1 is n square. Remember that formula. Now your n square gets cancelled. N plus 1 whole square by 4. That is your nth term. Now I got your nth term. Now, once again, write down the statement. Write down the statement. That is 1 cube by 1, 1 cube plus 2 cube by 1 plus 3, 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus so on, plus it is n plus 1 whole square by 4. This is your nth term. Just now we got it. N plus 1 whole square by 4. That is equal to n by 24 into 2n square plus 9n plus 13. Now listen carefully. First, for n is equal to 1. LHS 1 cube by 1 is 1. And in RHS, n is 1 I said. So n is 1 by 24, 2 plus 9 plus 13, because n is 1. That is 1 by 24 into 9, 10, 11, 11 plus 13 is 24. 24 gets cancelled. What I got is 1. Same, no? So your LHS and RHS is giving same. Therefore, your LHS equal to RHS. Therefore, the statement Therefore, the statement S of n is true for n equal to 1. Now assume the statement S of n is true for n equal to k. N equal to k means what I said. Instead of n, you put k. I'm writing that part here. That is 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3. 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus so on plus k plus 1 whole square by 4. That is equal to k by 24. Assume the statement is true for n equal to k. That is 1 cube by 1. 1 cube plus 2 cube by 1 plus 3. 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5 plus so on plus k plus 1 whole square by 4. That is k by 24. K plus 1 whole square. K plus 1 whole square by 4. That is equal to k by 24. 2k square plus 9k plus 13. This I will put it as equation 1 again. Now, to prove the statement, to prove the statement S of n is true for n equal to prove the statement S of n is true for n equal to k plus 1. Now, for that what I should do? Add k plus 1th term on both sides of equation 1. Add k plus 1th term on both sides of equation 1. Add k plus 1th term on. For that, what I should find first? K plus 1th term. What is your k plus 1th term in this case? Instead of n, you put k plus 1. So k plus 1 whole square, it's divided by 4, which is k plus 2 whole square by 4. This we are going to add on both sides. That is 1 cube by 1. 1 cube plus 2 cube by 1 plus 3. 1 cube plus 2 cube plus 3 cube by 1 plus 3 plus 5. Plus so on plus k plus 1 whole square by 4 plus k plus 2 whole square by 4. That is equal to k by 24, 2k square plus 9k plus 13 plus k plus 2 whole square by 4. Is it clear? Now let us solve this. Let us solve this RHS. Is it clear? Once again, I will write that RHS here. K by 24. K by 24 into 2k square plus 9k plus 13 plus, what was that? K plus 2 whole square by 4. That is k square plus 4 plus 4k divided by 4. 24 and 4 LCM is 24. That is 2k cube plus 9k square plus 13k. 4 6 are 6k square, 6 4 6 are 6 4s are 24, and this is 24k. I took LCM. Is it clear? That is nothing but 24 here. That is 2k cube plus 15k square plus 37k plus 24. Again, I got a cubic equation. Same here by inspection method, k equal to -1 is a root. K equal to -1, you put -2 plus 15 plus 13 plus 13 plus 24 plus 37 minus 37. See, you are getting 0, right? K equal to -1 is a root. Therefore, by synthetic division, reduce it. Synthetic division -1. What is that? 2, 15, 37, 24. You put 0 here. 2 plus 0 is 2. -1 into 2 is -2. Here what I get is 13. That is -13. What I get is 24. -1 into 24 is -24. -24 -24. What I'm getting is 0, no? Right. Now, k equal to -1 means k plus 1 is a factor. Into, now this is a second degree coefficients. That is 2k square plus 13k plus 24 by 24. Now k plus 1 by 24 is okay. K plus 1 by 24 is okay. Next, k 2k square. See, I want 2n square means 2 into n plus 1 whole square. So 2k square plus 2 plus 4k. What I am going to write it next? From 13k I wrote 4k means 9k will be left out. From 24 I wrote 2 means 22 will be left out. Is it clear? Right. That is nothing but k plus 1 by 24 into, once again. Now from here you take 2 common. Okay. That is from here you take 2 common. That is k square plus 1 plus 2k. That was the intention, to bring 2 and 4k outside. Next, here what I am having 9k plus 9 I want. Plus 9k plus 9. From 22, if I subtract 9, from 22, if I subtract 9, what I am going to get? 13, correct? 13 plus 9, 22 only, no? So from 22, I took out 9 common. So what will be left out? 13. That is nothing but k plus 1 by 24 into 2 into k plus 1 whole square plus 9 into k plus 1 plus 13. See, instead of n, you got k plus 1. Instead of n, you got k plus 1 or not? Therefore, the statement S of n is true for n equal to k plus 1. Therefore, by mathematical induction, the statement S of n is true for n belongs to natural number. Okay. So, yeah, in tomorrow's class, we'll continue with mathematical induction long answers. And tomorrow we'll finish off mathematical induction long answers. And with that, your long answers has been done. And day after tomorrow, we'll go for what we say, inverse trigonometry 4 marks and trigonometric equations few 4 marks, which will be helpful. Is it clear?